My name is Tim Schmit. I'm with NOAA Satellites in Madison, Wisconsin. My topic is the history of geostationary imagers as seen through the prism of the Bulletin of the American Meteorological Society. I'd like to thank my co-authors, and especially I'd like to thank the American Meteorological Society for digitizing all of the covers. Why look back? As part of the 100th anniversary, the AMS has digitized all the BAMs cover to cover. So articles, the covers, even the advertisements. Of course, we also recently celebrated the 50th anniversary of NOAA. And I think by looking back, we can understand how quickly remote sensing has progressed, plus maybe some clues of where we're going. So here's the cover of a BAMS from 1957, and it really talked about some of the potentials from what they termed an artificial satellite. For example, there were visual observations, they called them, clouds, cloud movements, drift of atmospheric pollutants, state of the sea or large lakes, visibility, snow cover. But then they also more quantitative, or what they refer to as radiometric observations, albedo, temperature at the level or near the tropopause, total moisture content, total ozone, or the ground temperature. Pretty remarkable in November of 1957. Let's fast forward, 1964, of course, getting ready for the satellite era included satellites, but also rockets as well. Here's one of the rocket tests from March of 1964. And high altitude balloons were critical for getting ready for the remote sensing from space. And here's a launch of a high altitude balloon from a mining pit, 1964 as well. High altitude aircraft. Here's an example of Hurricane Betsy from a aircraft as shown in the November 1965 BAMS cover. Speaking of the geostationary perspective, ATS-1 was launched in 1966 and had the cover here in February of 67. This had one green band on it, visible band. Quickly followed by ATS-3. So now with three visible bands centered at the red, blue, and green parts of the electromagnetic spectrum. That was launched in late 67 and was on the cover of BAMS here in 1968. Fast forward already to the 80s. There are many quantitative applications as well. This happened to be one of sea surface temperature from BAMS in 1987. We often think of these composite red, green, blue full disk as being invented in the series with AHI or ABI era. But here's an example from GOES in 1988 of a multispectral band composite image. Here's a glimpse to what was then to be the future. So 1991, an example of the effect of noise on total precipitable water derived from the what was then GOES Next or GOES I, which became GOES 8. Another example of the GOES showing the improved from GOES 7 on the left to GOES I again, which became GOES 8 on the right. Another quantitative was the atmospheric motion vector winds, where you take a triplet of three sets of images and track it and then estimate its height. I showed the color image from 1967 from GOES. It didn't really come back again until Advanced Himawari Imager, HI, and here's a beautiful true color image from that satellite in 2016. This BAMS article all had simulated data in it, but the cover was the actual first light images of the 16 spectral bands, 2 visible, 4 near infrared, and the 10 in infrared BAMs. So we put together a web page where you can step through some of these favorite satellite related covers. So and you can see here, you can start, stop, and step, and then you get the title. If you then click on this blue image, you actually get a link to the actual AMS page. So for example, if you clicked on that, you would get back to this January 57 example. So we made this movie, just my favorite 60 of the BAMs covered. Of course, the first one in 1920, first one with satellites, as I mentioned, example of a rocket launch, a balloon launch, the composite, field experiments, unique cloud patterns, high altitude aircraft, the groups at the White House, Tyros, I mentioned before the ATS-1, another example of Tyros and all of what can see, ATS-3, and just another example here, like this one. It shows a space station. It said we should put a meteorologist up in space to measure these things. And again, another example of clouds, loop current in the Gulf of Mexico, overshooting tops in the Soyuz, South America meteorology, looking at haze, water vapor, first water vapor imagery from UMEDSAT, hurricanes, quantitative 3D analyses, 3D perspective of clouds, tracking, and again, here's just satellites as one of the instruments. Mount St. Helens, very famous picture from 1980, visible image off the coast. Another idea of quantitative cloud, first images from lightning map, or not of lightning from space, from the shuttle, more atmospheric motion vector winds, other derived stability indices, three-dimensional perspective of clouds, again, sea surface temperature, another field experiment example, RGB, as I mentioned, INSAT, when they got there, I'm using these for vegetation, and again, simulated data to get ready for the next generation imagers. Toga Core, another field experiment, again, key water vapor drift winds. And I mentioned the Meteosat with the next generation, radiation budgets, pollution from space, for example, the GeoCape mission, Japan's AHI, ABI's Sweet 16, seeing dust. Again, here it goes. It's just almost a background image. So, and there we go to the new century, if you will. So 60 covers. Of course, they point not only where we have been, but where we're going. So, for example, geostationary imagers, starting with one visible and moving up the big step up with the ABI, and then we'll see what comes of the next generation imager. Another big step up in the spatial resolution, seeing things finer, and again, maybe next generation we'll get some 1 kilometer IR bands as well. That would be a first for us, and you can see the big step up was the improved temporal resolution with the ABI. Often as every 30-second imagery if both mesos are over the same location. When did things first come? ATS-1, first of its kind, first operational goes 1, orders of magnitude improvements goes 16. On the imagery side, sounding, first of its kind, we had VAS, experimental 1980, operational 1994 goes 8, and we'll see about the hyperspectral IR in part of the GeoXO program. In summary, BAMS has digitized the cover to cover. I'd like to thank them for that, and you could see the rapid progress of remote sensing. As I mentioned, they even did the ads as well. For example, Yon, private eye in the sky. Here's the 60 images all put together in one montage. So thank you for your time. There's a link to the web page with these covers. Thank you very much.